All right, so I'm Nick. I'm from Aerotech UAV. We provide a remote sensing service using drones and sensor technologies. So UAV stands for an unmanned aerial vehicle. They have a bunch of different names. So UAV, UAS, which is unmanned aerial system, RPA, which is remotely piloted aircraft. But they're all a drone. It's just one and the same thing. So I just wanted to show you this quick time lapse. And this was done by NASA, and it basically demonstrates it's a map of the globe, and it's mapping the heat signatures of the globe and showing the effects of climate change and global warming. So you can see as it hits about 1990 to 2000, the global warming effect really starts to kick in. So as you can see there, global warming is a big problem, and what's happening is the ideal climates for growing grapes is moving further and further towards the poles. So it's one of the reasons why Burgundy and Champagne are in a bit of trouble. So the other problem is that we're having is that the water quality is degrading as well. So we're seeing rising water tables, which is resulting in increase in salinity. And obviously we know that our water quantity is limited as well. We also know that vineyards are variable, so we're going to see changes in the vineyard from topography, soil properties. We have changes in fertilisation, the spray applications. The other significant problem that we're facing is the rise in population, which is resulting from an increased demand. So the global population is forecast to increase from 1.8 billion people to 3.2 billion people by 2020 and to 4.9 by 2030, which is an increase of 1.4 by 2020 and 3.1 by 2030, and 85% of which is expected to come from Asia. And you combine that with the recent free trade agreement that we've had with China, which I think was December last year, and it's fair to say that Australia is going to face a significant increase in demand for Australian food and wine produce. So how do we meet this demand by also combating the effects of climate change, water concerns, and all done with the same amount of arable land, because we can't grow more land? And the answer is through increasing our productivity and efficiency of farming practices through the use of technology, or in other words, precision agriculture and viticulture. And I've said here actually that vineyards are variable, and they are, but it's not entirely a problem. It's only a problem when we can't identify that variability and measure that variability, which is just one, and this technology is just one of the ways that can be done. I know that Mark's going to talk about measuring vineyard variability, but this is one source of data that you can use to measure that variability. In a perfect world, you'd have a number of different sources. So the soil moisture data that we had to talk about just before, some reflectance-based data, which is this, maybe some root circumference data as well. So have a bit of a data network, I guess is the better word for it. So this isn't actually a new technology. It's the same technology that we've been using in satellites and manned aircraft since the early to mid-70s in broadacre agriculture, mostly. It's just simply a new platform. And that platform has a number of advantages. Of course, satellites and manned aircraft have their advantages when you start mapping significantly larger areas. But there's the three main ones that drones have is their ease of deployability. So as you'll see in a minute when I go do a flight, it's actually quite easy to deploy them. Not saying that the process of remote sensing is easy, but they're easy to fly. They're also able to map quite a large amount of area with a relative amount of ease. So this one here, for example, the manufacturer says that you can fly around 1,000 acres per flight, and that takes about 40 minutes. So it's about 500 hectares for one flight. But probably the big one and the most important one is the resolution of the data. So because we're flying lower and slower, we're able to get a much better resolution, so getting better quality data. And at around 400 feet, which is where we fly at, we get down to about 2.5 to 3.5 centimetres per pixel. And this is especially important for a high value crop like obviously wine grapes and avocados and almonds as well. So drones have been used quite extensively throughout the globe. They've been used in the United States, have been really at the forefront, and Chile have actually been at the forefront of precision viticulture for a while now. And Australia's been really lagging behind adopting this new platform for a number of reasons. I'll just go into a couple of them. One of probably the biggest one is the regulation. We're actually the first country in the world to regulate commercial drone use back in 2002, and we still have that regulation today. They're changing it in 2 days' time actually, but it's actually not going to really free a lot of things up. There's still a lot of barriers to adopt this technology. And I'll go through it in a second, but the process of remote sensing isn't actually as simple as flying a drone and taking some photos and bang, there's your data. There's a bit more to it than that. A lot of things have to line up for you to actually get some meaningful data which you can then apply to your viticultural operations. And again, that can be really complicated. So because of this complication, it's quite time consuming as well. And finally, and probably the most importantly, is the delivery format of that you get the data in. So historically speaking, if you've ever got satellite or manned aircraft imagery, they often send it to you in a KML file or GeoTIFF file just via an email. And this is then really hard, time consuming and complex to take that data in that format and apply it to your field. Again, the format's quite an important thing. So I know there's going to be people in this room that have a lot of experience in remote sensing, and then some people that won't. So I'm keeping it really simple here. So what is NDVI? There's a couple of plant indices. NDVI is one plant indice, stands for Normalized Difference Vegetation Index. And there's probably two that are the most important. So NDVI and PCD is your plant cell density. So it's pretty self-explanatory. It's measuring the density of your canopy, whereas NDVI is measuring crop health, is the simple way of putting it. So when a plant photosynthesizes, it takes in a bunch of light in different wavelengths. In different bands. So you take in some green, blue, red, but it also takes in some near infrared light and red edge light as well. And why that's important to us is obviously the better health that a crop is in or a plant is in, the more chlorophyllic content it's going to have, but it's also going to be indicative of its ability to reflect that near infrared light. So by measuring that near infrared light, we're able to essentially get a measure of crop health. And again, the beauty of measuring that near infrared light is that it's not actually visual light. It's not visible to the human eye. So because the wavelength is too high, it's almost, you can almost say it's like an X-ray for a crop if you want. And it's simply just a formula of near infrared light and red light. And to get PCD, it's just a rearrangement of that formula. So the remote sensing process itself, to actually get to some meaningful usable data that you can then apply to the field, there's a couple of different things that have to line up, and I'll go through it really quickly because it's not really relevant to you. What's relevant is how you then take that and apply it. But the data collection is a really important process. If the data is not collected properly, then everything from here on in won't matter. So there needs to be a significant amount of what's called latitude and longitudinal overlap. So the flight path of, this is actually us, this is Nepenthe here. This is what I did on Friday. So this is the flight path that we take the images in. You basically do a number of pass-overs and collect, and every time, every 20 or 30 metres, it will take a photo. And all those images will get what's called stitched together to form one big image. And so when I'm talking about overlap, that's what overlap is. If it's not sufficiently overlapped, then when you come to do the processing stage, everything's going to be offset and your data's essentially going to be completely inaccurate. Another big trap that you can quite easily fall into is that there's a lot of companies that will market their products. They'll try and sell a drone, like the complete package of the drone and the sensor and the software. But what they quite often do is simply take a normal visual camera, so just a camera that you take a photo with, and they'll remove a filter to say that that's NDVI capable, and it's not therefore actually giving you a true NDVI reading because it's not measuring near-infrared light at all. So therefore it's not a true NDVI. Then you come to the data processing. There's a couple of different platforms that you can process the data in. You can use a cloud-based platform, and again, the issue of connectivity, which Australia is lagging behind with as well. That comes into question, so internet speed and connectivity. And then you can also process the data on just a program or a computer, but your computer needs to be able to handle enough, it needs to have enough grunt to be able to handle that demand. One of the most important, probably the most important thing is actually geotagging. So all those images need to have a geographical reference. Otherwise, when you're looking at an NDVI, how do you know that area? How do you know exactly where this particular area of variability is? So all the images need to have a geographical reference, and that's done by correlating the flight logs from the drone and the flight planning software to when those images were taken. And then you come to the delivery of the data. If the data is not delivered to you in a user-friendly format, it can be really time-consuming and complex to then actually apply that into your field. So we actually deliver all our data through an application that you can take out into the field, which makes it a bit simpler. So what can you do with the data? Well, this is an NDVI, and some of you might have seen it before. It's very, very similar to if you've ever done any yield mapping. Your yield maps are giving you a measure of yield. This is just giving you a measure of crop health. What it's really doing is, at the end of the day, you can do all these things with it, and people will say you can do this, this, and this. You'll save your costs and this, this, and this. But it's identifying your areas of variability so that you can make better informed decisions. Something that we do a bit of collaboration work with a company that's over in Napa Valley and Chile as well, and what they've able to do, and probably the biggest benefit they're finding from it, is identification of irrigation problems. So here, where there's red flag, yellow flag, and green flag, although again it's not telling you what the problem is, it's telling you where it is. You can make assumptions as to what it might be based on the patterns of what you're seeing. So because these areas are quite isolated and under high stress, they assumed that they were water leaks, and then they went out and ground truthed them and confirmed that. So it is actually important to ground truth all the data, and you're going to essentially do that by going out to the field anyway. This type of data, and what it's, in order to interpolate the data, it's quite simple. So obviously areas in green are reflecting more near-infrared light and therefore better health. Areas in yellow moderately stressed, and areas in red are either highly stressed or dead. So it doesn't matter what your role is, whether you're a grape grower or a winemaker or a advisor or even a stakeholder. There's definitely some merit in using this data. I was going to go into grape grading because grape grading has a significant impact in profitability. I won't mention who, but someone that I've been speaking to quite a bit actually measured how far one of their grape graders walked when they did their grading. And they told me that in one case, they walked 89 metres, had 11 sample points, and that equated to grading approximately their entire vineyard based on a 0.00028% of the total vineyard. So if you have a vineyard that's variable, which everyone does, then if they had walked in this part here, they might have graded their entire vineyard based on a very, very small sample size. So what this can be used for, if you're a grape grower, is to segregate zones and say, okay, well, this area I understand is not great, so this can be graded a lower grade, and this can be graded a separate grade as well, and as for the rest of the vineyard. On the flip side, if you're buying the grapes as well, it's giving you confidence knowing that if you're walking in this part here, and that might reflect, you might think that reflects your entire vineyard when in fact it doesn't. So it's giving you the tools to actually buy with confidence and knowing that the grade of grape that you're aiming to buy is in fact that grade. And if from an advisory point of view, it's giving you the tools to provide more accurate advice as well to your clients. And if you're a winemaker, you're also able to track your varietal blends. So obviously, by looking at the way that your vineyard is performing throughout the year, you're able to track or plan ahead in terms of which blocks you want to blend and which blocks you don't want to blend with. So just a couple of different data sets here. So this is NVI, and as you can see, it has a bunch of different colour classifications. This is simply a zone map, which is derived from NVI. It's just breaking down the number of colour gradients. What can be done with zone maps? Well, in broadacre agriculture, they're using this quite a bit to do variable rate application sprays and fertilisers. I know that's not a completely viable thing in viticulture. What they're experimenting with in Chile is also doing split picking. So by correlating its readiness to ripe for each colour gradient, they're then able to optimise or plan for their harvest much better. I have had someone ask me whether it can actually predict BOMA levels as well, and the straight answer to that is no, because it's reflectance based. It's measuring crop health, not sugar content. But you can take a bunch of, say, 12 or so randomised samples from a zone and correlate that to particular levels. So this one here is just the zone map compared to an NDVI, and you can see the variability is pretty consistent throughout. And this one here is quite an interesting one as well. This is your zone map derived from NDVI, so your crop health. And this one here is a topography, I think it's a topography and elevation map as well. So you can actually see the variability with a change in topography, you can see the change in crop health as well. So using all this data, at the end of the day, it's identifying where your areas of variability are. It's not telling you what the problem is, but it's giving you the tools to make those better informed crop management decisions. Do you have any questions?
What's the degree of error as far as the imaging? So, where you've got spots in your paddock in an NDVI image.
Yep.
Is that like within a metre or?
Between these 2 points?
A red dot in a paddock, and say, okay, there's a problem there.
Yep.
What's that degree of accuracy? Is it going to be to that row, or?
It's, like I said, the resolution's 2.5 centimetres. So if you really want to find out which leaf is unhealthy, then you could. It depends on, and that's part of the reason why the collection of the data is so important, because the height that you fly at will determine the resolution that you get. So obviously, the lower you fly, the more resolution. The higher you fly, the less it is. But yeah, it's around 2.5 to 3.5 centimetres per pixel. So it's quite accurate. Say that again, sorry. The geotech is very good, yeah. So when the drone flies, I think it uses about 13 or 15 satellites. So the location's quite accurate. Sorry? I'm not sure of the actual number, no, but yeah, it's using a number of satellites.
Look, Nick, what we might do is do the run afterwards.
Yeah, sure. Yep.
So look, the opportunity will actually run this drone after the session. So thank you, Nick. I'd like to move on now to the next